Hello class, Professor Anderson here. Let's talk a little bit about the displacement vector. So what do we mean by displacement? Displacement is moving from one location to another. So if you think about moving in a two-coordinate system, X and Y, a two-dimensional system, we need to know a couple things. We need to know where you started and where you ended. So let's say you started there and you ended right there. How would I define those positions in this coordinate space? The vector from the origin to your initial location is S sub I. The vector from the origin to your final location is S sub F. And therefore, delta S is going to be the difference between the two. It's going to be the final location minus the initial location. And we know exactly what that should look like. It should look like that right there. From where you started to where you ended, that's what delta S looks like. Now let's convince ourselves that this is true based on our rules for vector addition. So one thing we said was if you are subtracting a vector, it's exactly the same as adding the negative of that vector. Okay. SF looks like this, up and to the right. SI was up and to the left, which means that the negative of SI, you just flip the arrowhead. Okay? Same length, just opposite direction, so it would be down and to the right. So it would be something like that. And now I'm just adding two vectors. How do I add two vectors? I start at the beginning, I go to the arrowhead on the end of the last one. And now that delta S, which is roughly how we drew it over there, is that long and it's in that direction. Okay? So adding vectors means this tip-to-tail method applies, and anytime you subtract it, you're really just adding the negative of it.